Hello. In this screencast, we're going to go over some of the basic voltage and frequency mapping tools in Persyst, the ones that are right at the top of the user interface. Show you a little bit of what's in there for the more advanced tools, and we'll show you how to use them. I'll just do a quick overview of what we're going to be looking at. This is Michael Guest, VP of Research and Clinical Applications for Persyst. This is a recording ambulatory 24-hour patient has spikes during sleep and some seizures that are predominantly left with some spread to the right. Well, first thing we can look at is the ability to do voltage mapping. And this is from the spike review program. I've already selected some spikes in a spike cluster, and I'm showing the overlay of the averages of these. And I'm showing a propagation map where we have time 0 is in the middle. And then we're going 10 milliseconds at a time. So this is a propagation map where we can see, is the spike starting where, in other words, the onset of the spike is about where the peak ends up to be. And it's not, the source isn't moving. So this is an example of propagation maps. We also have frequency maps. So that's done from Insight 2. We're going to show how to do all this, but just giving you a preview so you can see what the options are right at the top. Here I've marked a range of EEG, and I'm going to go ahead and go to properties here and make sure my data ranges are set to do the ranges, and we'll select OK. So it's going to use this range, and what we can do is just walk forward through the seizure. If we go from the onset here, we can see that we have a lot of power in the alpha band here, left. As we go further into this, we can see that we're beginning to see some amplitude here in theta and delta. So we're looking at delta, theta, alpha, beta. This is the FFT graph for each channel. We're looking at this in the Laplacian reference. Whenever you're doing mapping in Insight 2, you always want to make sure to pick a referential montage. What I can do is page through this. I've just arbitrarily picked a 4-second or 3.99 second range. And as we advance through this, we can see we've gone from alpha to really just showing up in the theta range, which we see from the waveforms as this evolves from faster to slower. Now we're seeing some picking up in the delta map. And so that is an example of doing voltage and frequency mapping. Let's go ahead and see how we went about that. I'm going to go ahead and put these back to the original positions, and we're going to close this. I'm going to even close the recording, and we'll go ahead and get started through those steps. Very easy to do, because those are the ones at the top of the user interface. And again, even the more advanced tools are fairly easy to use as well. We're always happy to meet to go over those. So I've launched Persyst 15. This happens to say Rev B. These mapping tools also are in Persyst 14 as well. I'm going to click open. This is used in the database. Something to keep in mind, the Persyst database. There's instructions on how to set that up in the user manual under the help button. And we can also meet by web conference with our support team to show how to do that. One of the things you can do, though, is if you have multi-part recordings and you wanted to open up all the recordings under a particular patient day, these are 2-hour stages for this particular one, that's what that allows you to do. It'll go ahead and pull all these records together. Now, as we're going to go and look at mapping and so forth, we'll go ahead and pick a different record, but this is just to show that something that may be of interest when you're marking spikes, mapping voltage and propagation for those. You may want to use a full selection of the record while you're doing that. And this is taking a little bit longer because it's opening a whole bunch of records at once. Once that bar completes its journey across the screen, I'm going to click the patient button here, and you can see it's opened up all those as a single recording. So if I go into spike review, or if I'm going through trends, it's going to treat this as a single long recording because it's the same patient name, birth date, patient ID, and so forth. So it knows to associate those. All right, so I'm going to go ahead and close that. Let's start with that EMU recording that we had that initial look at. I'm going to click open, go to my database, and these are my teaching files. So I'm going to do this seizure spike during sleep. Sleep research, P15 does have full sleep staging it. And the clinical product has sleep-wake. And we'll see where that's helpful as we go as well. This is the default trend setup. Since this is EMU, I may actually go to my sleep-wake set of trends. The AEEG panel is in Persyst 14. Persyst 15 gives me AEG sleep-wake. And you can see here saying the patient's awake, which is true. And As we go a little further along, we see some alpha here. Let's just go right up to where that seizure begins. And so we can see here that the sleep state has gone from wake to sleep. We see an increase in left temporal detections here, according to this, where we're looking at left, right, vertex, and generalized. So we get some localization information here. As we page through some of the EEG, we can see the patient is indeed asleep at this point, and there's some of those left temporal discharges. So let's quantify these with mapping and with averaging. So I'm going to select the spike review button, and this is the first level of mapping. And there is a separate screencast. I'm using Persyst 14D or later spike review and Persyst 15. So let's pick this first group. It says T3, 548 detections here. And I've sorted them by perception. You can do that by amplitude as well. But sometimes perception can give you nicer results. That's more or less a probability. So I've already selected some, 20 of these. And if I click this second button here, this will allow me to go through and select additional candidates. Typically, this hand selection of spikes is about picking candidates by clicking a box around them and deciding if you want to add that to the average. And then I can look at this third button here, which shows me them all overlaid one on the other. So the propagation maps are right here at the top. And so this bottom map is showing me the selected one, and then these are all the confirmed. You can see n equals 21. That's the average I'm interested in. So in some cases where there's propagation, you can use a propagation map. And that's the first class of voltage maps that we'll look at. We looked at a single map, and this shows that we have maximum negative amplitude here in the left temporal. And if we go to a propagation map, we can see if it's starting in one place and ending up at peak voltage at another, basically speaking. So there's more to it than that, but that's a propagation map, and that's the first type of mapping that we can do. Now, if we want to do some other voltage mapping, we'll look at the ability to do that using the Insight 2 program. That's where another whole collection of tools is available. But let's go ahead and save some of these. So I've marked a number of these, 21. I'm going to go to my final report, and then I'm going to go to Tools and Mark Groups as Voltage Plot Comments. And what that does is it marks them in Persyst with vplot. Group 1, Group 2, if I had marked more than one group of spikes. In this case, I've only marked one of them. And if I sort this alphabetically, those are those voltage plot groups. We're going to use those to do some voltage mapping. So, and you can use those for other purposes as well, but let's go ahead and go to the Tools menu and launch Insight 2. We'll start with voltage, and then we'll go to frequency mapping. So it's taken us to this part of the recording, and as you remember, looking at the trend display, we also have some seizures here. So prior to the seizure, we see some of those left temporal discharges, but we picked some from throughout the record that were exemplars. Let's go ahead and minimize that out of the way. And what we had done is we had selected the Insight 2 button. Now there are a whole bunch of buttons up here. It's the same program, but the important thing to keep in mind is that, and it synchronizes together, this one gives you an additional set of tools. So first thing we want to do when we're doing any kind of voltage mapping is we want to pick what do we want to do the voltage maps on. I'm going to go ahead and display that comment list, and I'm going to size that appropriately over to the right. And so all these are drag and drop. And again, this is different from the Persyst interface, but it's the same program. And I'm going to sort these by alpha just by clicking the text column, and I want to put those vplot comments up at the top. And I can just arrow down through these and see these are the spikes that I picked out from Spike Review. Now what I can do is just, well, let's start with mapping one of them. Now I'm looking at this in a bipolar longitudinal montage here. So if I click on the EEG page and I pick this drop down, mapping with a bipolar doesn't make any sense, but Persyst lets you map with any montage you like, because you may want to use an average reference. You may want to use a Laplacian, which is a type of average reference. Let's use a Laplacian. Just keep in mind that whenever you're doing topographic mapping, you want to use some sort of referential montage, usually not a vertex reference, because again, then you have varying electrode distance from that reference. So let's go ahead and pick an average 12 montage and look at how it appears there. Now if we pick a Laplacian, it's going to be localized a bit better, but a bit lower amplitude as well, but that's fine for our purposes. I rather like a Laplacian for mapping. Now this is an average where each electrode is averaged to the ones immediately surrounding it, basically. So let's go ahead and do voltage mapping. Now here there's a button that says NA, and there's a couple of pre-built analysis tools, so you don't have to make them yourself. And then I'll show you can customize things as well. So we're going to pick vplot. And right away it's showing me a voltage plot of this. Let's go ahead and make some changes to this. I want to right click, go to properties, and I want to show the average of the waveforms. And I'm going to pick data ranges because instead of just the caret time, which is wherever I'm clicking on the screen, actually let me show how that works. So wherever I click, it's going to change that map. That may be fine for just a quick display, but what we want to do is go one step further and actually tell it these are the things that I want to average. So let's go to properties, data ranges, and I'm going to go ahead and select events as cursors. And I'm going to do selected. So what does that do? Well, I'm going to pick this voltage plot, event, and again, that's one of the spikes I marked in Spike Review. And what I can do is just keep adding to this average. So I'm holding down the shift key and I'm clicking that down cursor arrow on the keyboard, and you can see that now it says n equals 15. So what I'm doing is I'm incrementally adding to this, and well, frankly, I'm back averaging this. So those are the group ones. I actually have some group twos that were marked from a previous exploration. Those are probably some P3. Yep, those were the P3 spikes that I had marked earlier. So, not in this particular example, but in this particular recording, there are some rare P3 spikes, but most of them are T3. Okay, so that's how to do some voltage mapping. And again, I can select one or more of these, right-click. I can go to those properties page and make some changes. Now, for back averaging myoclonic jerks, that's a little different. You can actually set a pre-duration, let's say of a second, post-duration of perhaps 3 seconds. And obviously this is not myoclonic jerks, but you can see this allows me to hand place cursors and change the duration of the average display as well. That's just an aside. Let's go ahead and set that back to where it was. So we had 0.5 and 0.5. Okay. That's voltage mapping. Let's do some frequency mapping. So I'm going to go ahead and close this so I can start from the beginning. And I'm going to use the trends to navigate to a point of interest. Let's go ahead and just page forward through this. And the trends, I'm going 30 minutes at a time, which is good for seizure hunting. And if I'm doing a review, I actually may want to fold some of these displays out of the way. They just become tabs. Go a little further along until this is the point of interest. Let's say I want to map this distribution of frequencies for the seizure. Let's go ahead and go back to Tools and Insight 2. Didn't have to close it, but I'm using Persyst to navigate to the point of interest. And I'm going to move that comment list over to the right. Actually, I don't need the comment list at the moment, but again, I can turn that on and off right from the toolbar. And I have artifact reduction on because without that, we've got a lot of muscle, and that's going to confound things. So we're still in our Laplacian montage here in Insight 2. And again, you want to use some sort of referential montage to do this. Let's go ahead and pick an average 12 montage. Either one will work fine. And we're going to move backwards a little bit to where we're around the onset. And we can toggle the artifact reduction. I like to use that to spatially separate the physiological artifact because that's just going to contaminate the maps and so forth. So let's go ahead and get started. That map is pre-built. FFT, D tab, delta, theta, alpha, beta map. And there it is. So I just picked it from the drop-down. And by default, it'll do the current page. So if I move this over to the right, you can see when I put my mouse between the FFT graph, which is the power, by frequency band, each one of these vertical lines is one of the bins. So we're going 1 to 4, 4 to 8, 8 to 13, 13 on up to 30. You can modify these, of course. So if I right-click on this and go to Properties, those are my frequency bins right there. You can change that. This is getting into some of the advanced mapping. But again, I just pick this from the drop-down menu, FFT DTAB map, and it wants me to put in a range. So I'm going to go ahead and insert a range. I'm going to remove that fixed position of new cursors, and I'm going to insert a range. And the reason I'm not fixing the position of new cursors, I want to drag this around with me. So I'm just going to make this about 5 seconds. I can make it a little shorter. Let's drag that back just a bit. Okay. So now I've got a range there, and I'm going to reselect this. Okay. Move this over to the right. So I can resize these. I don't need to be quite as wide there. I'm going to move that over. Okay. And what I could do, let's make this just a little bit finer adjustment. Two seconds. 4 seconds. Perfect. Okay. And you can pick whatever duration you want. But what I'm going to do is, using this average reference montage, I've set a range here of 4 seconds. And if I right-click over on these graphs here and go to Properties, and this data ranges, I've said to use, I'm going to tell it to use ranges and visible or selected. These are the visible ones. So now this is only going to, instead of using the full page, it's going to use that range. So as I move forward into the seizure, we should be mapping that as we move forward. Let's make it a little bit shorter. There we go. And we've got some lower frequency stuff here. I think that Laplacian is going to work a little better. Yeah. Again, I like a Laplacian montage. We had some low frequency artifact going on there. So this is the onset of the seizure. And I can move this, make it 2 or 3 seconds. And we'll see at the onset of the seizure, we're getting amplitude here around P3, more so. T3, P3 in this range. In the alpha, beta is not really lighting up too much. We're getting some of this delta just showing up around the edges. And as we move forward through this, let me just drag this a little bit at a time. You see that the alpha fading away and is starting to light up more in the theta and delta range as we go forward through this. Once we get past some of this artifact here, we can see that really lighting up T3 in the alpha and theta range. We'll go a little bit further. And as the seizure evolves from faster to slower, we see it's disappeared from the alpha. And what it's doing is it's mapping these peaks, showing up here in the turquoise. As we go a little further, we'll see it lighting up in the delta. Eventually, it's going to fade out from that theta range. As we go a little bit further along. And then eventually we get to the offset of the seizure. And that's the end of it. So there's the frequency mapping tool. Easy to use at the top of the user interface. There are additional tools, and we have a pretty extensive clinical application note that goes through all of them. But and I'll just show that real quick. If I right-click, launch Insight 2 again, and I'm just going to right-click over in the right part of the screen, insert vertical adornment. You can see there's a whole lot of stuff here. There's wavelet transforms, bispectrum, component analysis, independent and principal. And for instance, if we go to frequency domain analysis, that's where that pre-built one was. And we go into properties, we can see we can do phase encoded Fourier spectrum analysis, coherence analysis, and so forth. So lots of tools in there. But the basic mapping, again, if I just right-click, delete that, is built in. And you can pick it with just 2 clicks. Click this drop-down, go into the DTAB maps, and there you have them. Again, this is Michael Guest, VP of Research and Clinical Applications for Persyst. Any questions, feel free to contact us at support@persyst.com. Thank you.